Here we go. All right, so you should now be able to see the introductory slide of the beginning of the workshop. It's my great pleasure to welcome you here today. I hope other people will be able to join us on site. It's been a tricky start of the project in a way because of the timeline of the British Council. We had planned to have an early workshop during this 1.5 year project, and we had basically to start relatively quickly. We got the notification of the funding mid-January, and we were supposed, and we started the project early February, and here we are about a month later, and we are trying our best to have this very exciting workshop in the next few days. Unfortunately, we've had a slight setback in terms of welcoming people in the UK because of the current situation in the Middle East. So it's not such a currently terrible situation in Saudi Arabia, although it's certainly tense. But of course, we have still some flight disruptions, and of the several people from Saudi Arabia supposed to come here today, only 2 of them managed to be here with us because essentially they were doing some business before in the UK, just happened to be here a few days before chaos started. So I'm really sorry about this, but the good thing of technology is that we can still retain the key elements, some of the key elements of the workshop, including this interaction today. So we'll do it through this video conference. So I'd like to thank many people, maybe as a start, so all of the people here, all of the people online. I'd like to also thank my main collaborators, so Floke van der Span, who's a professor in igneous petrology at Coast, Caroline Nemeth, who's a volcanologist and someone very interested in geoheritage as well in the Saudi Geological Survey. Alan Bowring is not with us today, but he will be welcoming us in the Geopark, actually not far away from the picture on this slide. And of course, there are many other people I should thank, and I don't have the time. But the idea of the project is very much to build a collaboration. This is the essence of this project, and I think we are up to a very good start. So you should have had access already to the programs through my LinkedIn account. So just look for David Brooks online, and you will find my LinkedIn profile. I'll just go through the program as part of the introduction now. Just before I do that, I wanted to say that yeah, this is the beginning of a collaborative project. As I explained, there will be a range of collaborators, but this is also the start of a 1.5 year research project trying to understand volcanosilimetry processes in some of the volcanic environments of Saudi Arabia. So we will not really cover many aspects of the research today, although it is very much linked to the Geo-heritage component, but it is a Geo-heritage workshop. It's not necessarily a conference. So what we're doing is we are setting up the stage for the continuation of this project, and we're really trying to start with the right ideas and the right setup to do things properly and in a relatively short time scale, which is 1.5 years of the duration of the project. We hope we will reach some tangible outputs with real benefit for people in Saudi Arabia, and also maybe in some of the scientific communities interested in geo-heritage. So to do that, so there is that welcoming session that will last for another few minutes. Then we'll have Frauke talking to us about the Harrat volcanoes of Saudi Arabia. It's going to be a general introduction about what we know about them. And then we'll have more natural hazard aspects presented by Caroline, who's currently in Saudi Arabia. Then we'll have a short break on our side and on the side of the people abroad, about 15 minutes. And then I will follow this up with really diving more into geo-heritage aspects. So there will be more like, that's going to be an introduction about maybe historical aspects of geoheritage in the UK, and also how that could tie to geohazard, which is a relatively innovative, I think, component of this project. Also, we'll have Carolee talking to us again about the geodiversity of Saudi Harrats. And then in blue here, between 11:30 and 12 UK time, we'll have a discussion. And I've put this in blue because I think it's important. We really want to share ideas and maybe, discuss some potential challenges that are awaiting us. It's a workshop, as I said, so this is really an important aspect of this morning. For those of us with us and who have registered, some of them might be in this room, some of them might not have made it today. Just to make everyone aware, the workshop is really designed in a way that we can share experience, and also we wanted to capacitate as much as possible people that are not necessarily aware of what is exactly geoheritage. And you can do this in a few ways. So we've got a series of lectures this morning. Tomorrow we'll use our fantastic local geology, which is really world class. We'll go to the Glamorgan Heritage course with very good weather, which I have to say it's not been so typical early this year. But finally, just for the workshop, the weather is clearing up. And so we'll do some geosite evaluation exercise. We'll look at the geology, which is pretty exciting. The landscape is amazing. We'll have some of the highest tides of this year. So we're expecting 10 to 12 meters of tide, so it's quite impressive to witness, and it exposes a big chunk of geology. So we'll spend time there and talk about geosites. We'll also try to see how we can tie this to geohazard communication. It's going to be one of the main questions for the activity tomorrow. Then on the following day, on Thursday, we'll drive to the nearby mountains in Banau Bricheniog National Park. It's also known as Brecon Beacons. And we'll talk to people of Forestvaur Global Geopark, so UNESCO Global Geopark. And it's going to be really about learning from them what is a geopark, not only in terms of theory, which we could cover to some extent in a lecture here. It's going to be practical aspects. We want to talk to the people managing the geopark and the people also contributing to some very successful aspects of the geopark. And again, there is an element of capacitation, but also sharing what will be our needs in Saudi Arabia. And I'm sure the very experienced people of the geopark in the Brecon Beacons will be able to help us how to maybe conceptualize some of these aspects. I'll have to talk a little about the research project before we start the presentations, the more detailed presentations, just to give you a bit of context. So in short, we want to study geological processes and geohazards which are related to the formation and erosion of Harrat Lunayyir intraplate volcanoes in northwest Saudi Arabia. They've been active for a few tens of million years, possibly, but definitely also in more recent times, and they might still pose a geohazard threat in terms of volcanic threat, but they are also eroding, and that is feeding other types of risks and hazards, which are very much at the core of this project. So for this reason, the main goal, and these are the goals as they were written in the research proposal, the first goal is to determine how old and recent volcanic deposits contribute to regional sand and dust production, because this sand production is really linked to some of the hazards. It's also linked to the evolution of volcanic systems through time, which is something that has perhaps not been studied as much as it could have been in the past. People either do volcanology or they do sedimentology. This project very much aims at bringing these two subdisciplines together to address questions with a slightly different angle. The second goal is to develop with Saudi stakeholders, and it's obviously really important in a collaboration project, a geo-heritage framework. We will explain what it is this morning, to inform local communities about their volcanic heritage and associated risks to build a resilient society. Of course, that's a sort of wording that's always very pleasing for a potential funder. We really mean this. This is really what we're trying to achieve, and I think geo-heritage is a very powerful tool to achieve this goal. And then, and this is a more speculative element of the project, but it's only a project for 1.5 years. So there is definitely a pilot element in this project. We're going to try a few things that have not been done extensively before, and we will assess what are potential outcomes. And we can build upon that to hopefully continue this project. This is a sort of a collaboration, which we envisage will extend well beyond 1.5 years. So we hope. So this third goal is to assess possible roles of climate change, like long-term desertification and increasing frequency of extreme weather events. So it's very much a societal challenge. And you know how it links to geohazards and how it can potentially also link to other continental volcanic environments in semi-arid or arid settings. So it's very bold, obviously, and will not fully achieve that question in the framework of this project, but we need to ask that question because we want to collect data to keep on trying to address this thing collectively in the future. So this project is very much about bridging communities, but also bridging sub-disciplines in earth sciences. As I've already said, we will link volcanology to sedimentology. We want really to assess how much primary volcanic products have been remobilized, reworked in the environment. When I say primary volcanic products, for those of you that are not volcanologists, I mean products that are basically particles, grains, that have been produced during volcanic eruptions and that have not been reworked. As soon as they start to be reworked, at least some definitions say or consider that they become sedimentary products. So we want to really understand the amount of production and reworking of loose material in the Saudi Harrats. And then we want also to link geohazards to geoheritage. To do this, we will develop a geoheritage framework. And this is something I'll try to cover together with Carolee later this morning. We really want to make this tangible in the sense that we want to produce things that will be useful for local communities. And we're really lucky that by chance today we've got a communication officer from Coast. So it is obviously one of our key partners in the project. So anyone also online interested in promoting this idea in Saudi Arabia, just be aware that we're starting this project and we're not an exclusive club. We want to work with people. That's the whole idea. So get in touch with us if you want to contribute. So the project, how is it going to work? This is kind of a traditional way of, I guess, selling a project to a funder. In one sentence, we want to harness geoheritage to promote community resilience towards natural hazards. That's the topic of this workshop. We'll revisit the idea in the discussion at the end of this morning. So we, like in all projects, we start with an existing understanding of the geology. Some work has been done already by the Saudi Geological Survey in the study area about geosite characterization. So there's already some understanding of the geoheritage there. But we've got remaining challenges, including still we're not sure about the geohazards, some of the geohazards components in that area. Then we're going to do some new research. We're going to expand the geoheritage framework or create a new idea, concepts, we'll see. And then we want to create benefits for stakeholders. We want to enhance community resilience and so on. And this is really the traditional way of setting up a project in the sense you've got a starting situation, you ask your questions, you do your research, and then you have got some outputs. And I think this is not the right way to actually do this properly in the context of a geoheritage framework. But I cannot, so this slide is basically not good. But I'm showing it to you because I will challenge it during my presentation in an hour or so. So I'd like also you to, if you can, right now, as we're gonna allow Fouquet to come here and start the presentation on the volcanology aspect or igneous aspects of the Harrat. I would really appreciate if you could take some time at some point this morning to take the Menti. It's a small questionnaire. I know we all hate questionnaires, right? We do too many of them. So please take these questionnaires for us. We do this because we want to understand what is our audience. I think in a communication project, it's always a key element. So I am, and I guess our funder and our collaborators are curious to know who's here and for what reasons. So there are just a few small questions about this. I will show again this QR code and all the information how to access the questionnaire later this morning. So that's it for me. I don't know if you've got any question here or online. We're kind of flexible with the format to some extent. We're already a little bit late, so we'll have to move on though. Okay, thank you. Okay. Stop sharing this. Your presentation. Start. Not sharing now. Let's take on to this. So you can use the arrow or the mouse if you like as well to move around. Thank you.
Thanks. Well, and thank you for hosting me here at Cardiff. I wish we would have had a few more people here from Saudi, but I will try to keep it up from the Saudi side. So I will introduce to you a little bit about the Saudi Harrats, so which is the topic of what this project is about. I will start with a quite general presentation. Of course, not only my work, but I need to move this closer. Or...
No, it's all very good. I'm sorry. I just want to dim a little bit the lights. Very sorry about this. You're doing very well.
You don't want to see me.
That better for people here? Do that? Oh, it's better. Okay, good.
Okay. Good. So, of course, this is based on some of the work that we are doing, mostly an overview just about the Harrats. Other people have been involved as well. Some of them mentioned here. Trying to move on. Okay. Before I dive into the Harrats, I just want to have a few words about where I am, where I come from, what is KAUST, because KAUST is a very young university, only about 15 years old, and most people don't even know it. So we are in Saudi Arabia on the west coast, right next to the Red Sea. And KAUST is an international university, of course, also with a lot of Saudis in KAUST as well. But it's one of the things is that it's really a mixture between many different cultures. And I think that makes this university a unique place in the world, because people from all around the world are working together on topics that are of relevance for Saudi Arabia and as well for the world. It's also the first mixed gender university in Saudi Arabia. So we have quite a large proportion of women in KAUST. It's not a very big university. We only have master and PhD students, something about 8,000 people in total that are living there, but not all of them are students and academics, of course. And within this university, I have my working group on volcanology, petrology, geochemistry, and we work in general on magmatic hydrothermal processes from source to eruption. And this is our playground, Saudi Arabia and the Red Sea, because we have a lot of different processes happening there all together. There's the continental breakup of the plates, there's mid-ocean ridges, there's interplate volcanoes, there's the Afar plume to the south. So we have a lot of things happening in Saudi Arabia. So just for the people that do not know Saudi Arabia at all, I have here some geological maps to give a sort of a very general background. And we can sort of split Saudi Arabia into two parts. There is the Arabian Shield, which is on the right map, the pink area. And it's also indicated on the left side where you have the different terrains of this pink area. So this is the old Proterozoic shield made up of volcanic terrains, which are all amalgamated together something like 600–700 million years ago. And then there is the Arabian platform on the other side that are mostly sedimentary successions, Paleozoic, Mesozoic, and that's where most of the petroleum is. So most of the geology has been focused on the eastern side, where we have all the hydrocarbons, because this has been the most important part for Saudi Arabia. We will be focusing on the western side, and not necessarily on the shield, but on the bright pink spots that are on top of the shields, because these are the young volcanic areas that we have there. And these volcanic areas are called the Harrats, which is the name for lava fields in Saudi Arabia. So, and these Harrats are actually one of the largest Cenozoic intraplate volcanic provinces worldwide. Most people are not even aware there are volcanoes, but so all these purple areas are volcanic fields. So you see they cover huge areas. There's something like 13 fields and a few smaller ones on top of it. And each of those fields is made up of many individual vents. So there's more than 2,500–3,000 vents, and each of those was a single eruption. Something else which is quite important is that we have not only basaltic volcanoes, but also felsic volcanoes, which you see here in the satellite image. And it's actually an amazing place. The volcanoes are super fresh, super nice, great for camping. They also did some sort of touristic attempt, not entirely certain if they do that this year still at the moment. Now, after I've explained to people, yes, we have volcanoes in Saudi Arabia, you know, these black rocks that you're driving over are actually volcanoes. The next question I always get is, are they active? And they are definitely not active. So the last eruption that we had in Saudi Arabia that was well documented was in 1256, about 800 years ago. And that is this black areas right next to the city of Medina. So at that point, the lava flow stopped just at sort of the gates of Medina. Right now, the city has been grown over the lava flows. So if we would have an eruption very similar as what we had that in a similar location, then this city, which is receiving millions of pilgrims every year, would have a large problem. Apart from this well-documented eruption, which was next to the city, there's also, I would say, sort of rumors. There's information that there have been eruptions at other times, as late as 1800, whereby it's a little bit unclear where this eruption was or if that really happened. We're actually trying to do some dating of some of these young eruptions to get a better understanding which of these eruptions are really young or maybe older. Apart from these eruptions, there also have been much more recently, in 1999 and in 2009, there have been earthquakes which have been associated to dike intrusions. So these are failed eruptions that did not make it to the surface. So this clearly shows that the system is still active. One place was Harrat, which is what I just showed, next to Medina. The other place is in Harrat Lunayyir, which is a topic of our project. And this is an area where there's a large development going on. It's called Red Sea Global, with the aim to attract tourism to this area. And also, if we just look at the larger system, looking at to the south, the Afar region, southern Red Sea, there have been eruptions recorded even last century, and shortly before the end of last year, there was this eruption in Ethiopia, which also could have affected Saudi Arabia and the air traffic if the wind would have been in a slightly different direction. So the system itself is active, and there is a potential for geohazards associated with it. Now, looking a little bit at the volcanoes, I already mentioned we do have not only basaltic volcanoes, we have also more felsic eruptions, and we have a whole range in the Harrat from the small tephra cones, slightly more explosive ash cones, but we also have a large crater, the Waba crater, which is a maar explosion. So there is a potential for more explosive eruptions in this system. Now, to get this more felsic, more explosive eruptions, we often want to have a look as geochemists, petrologists, at what's happening as magmatic processes, as this can really change a system from lower volatile, more mafic to a more felsic, more polygenetic, more complex system. In the Harrat, typically this is said that's not really happening. We don't really have a lot of magmatic processes. So most of the basaltic volcanoes are thought to come straight from the mantle, nothing happening in between. For the felsic volcanoes, we must have some crystallization, but there's no thought of a lot of things happening, and definitely most of the previous research always said there's no interaction with the crust at all. Now, in the last years with my students, I've been working on this question, and we do find that we have storage in the crust. We do see a lot of evidence of magma mixing. We also found the first evidence of crystal contamination. So there is definitely much more happening than that was earlier said, but this is still work in progress. Now, another important thing when we talk about the Harrats is trying to understand why these volcanoes are there. Because it's a huge province, and actually we don't really understand why there are volcanoes. And the reason for this is that the ages are, so they have been active since about 30 million years ago, since the start of the opening of the Red Sea rift. But they don't, and since then we had volcanoes all around the length from south to north, but these ages have been random. So if you think about different models, it doesn't really fit with rifting. So it's maybe related to the rifting of the Red Sea, but the Red Sea was rifted next to the Harrats, and the Harrats are sort of offset to the rift at the moment. If you think about plume models, you expect an age progression, which is also something that we don't see. So these are the two models that have been proposed for the Harrats. On the one hand, related to rifting, there's different arguments for this. I just mentioned a few there based on the chemistry. This is mostly thought to be relevant for the older magmas. On the other hand, there's this thought that maybe the upper plume is sort of flowing under Arabia instead of going to the Red Sea, going northwards. Again, there's different arguments for this, but we haven't really figured out why we have these volcanoes there. And it's maybe something in between. There may be some other aspects there as well that are of importance. Again, something that we hope to get more insights in the next years. One thing that we have found is that the mantle underneath Arabia is very complicated. This is just illustrative. I will not go into detail. The main thing is you see a lot of range of different samples, and that indicates that we have a very complicated history of the mantle with depletion events, re-enrichment events, which can lead to these different sources that we see in our volcanoes. So in general, we have lots and lots of open questions still about their origin, about magmatic processes, but also something which has not been looked at in too much detail actually is the exact hazards associated with them, as well as a potential value that we can gain from the Harrats. Because mostly they're just there and people are not even really aware what they are. And I think we can do much more to it. So because we will be talking about some of these, I will just introduce the Harrats to you. And I will start in the south. going to the south. So we are here in the furthest south. We have two Harrat fields. The one is Harrat Alberg. The other one is in the Jizan area, which is actually south of Alberg, but those volcanoes are just single cones that are so small that they don't fit on the map. But there is activity there, and this is actually a location where it's said that there may have been an eruption in around 1800, so very, very recently. Most of these Harrats are basaltic. They have a lot of mantle xenoliths in them. And just two things that are interesting to note about these Harrats is that there's also rift-related volcanism in the area, which is older, which is called the Jizan group, which should not be confused between the two. And the other thing is that there are several hot springs in the area. Now, they are not thought to be volcanic. They're thought to be related to the escarpments. But at the same time, if we have some hot areas, no one actually looked at the relation with the volcanoes in that area. Moving northwards. Here we go. So a little bit further north, we have these three fields, Harrat Kish, Hadan, and Narasif Buken, whereby Harrat Hadan is the oldest one, has been active since around 28 million years, has partially been eroded as well, so there's not that much left, mostly the deeper parts. It has not been studied too much, actually. Also, Narasif Buken is not that much studied, and that one is quite interesting because it has a little bit of different orientation compared to all the other Harrats, and we don't really understand why that is. The one that has been studied quite a lot is Harrat Kishp. Has also been recently as in geological time, we see very fresh Harrats being present there. And this is the first Harrat coming from the south, which has also some more trachytic rocks and not just basalt. This one is very interesting because it has a lot of mantle xenoliths, and these mantle xenoliths have gem quality olivines. So there's actually a small mine there where they are processing these olivines for jewelry and things like that. And this is the place where we have this big Mawrth crater, so where we have these large explosive eruptions some point in the past. Trying to go up. Oh, it jumped up this time. So moving forward, we have one very sort of connected field, Harrat Rahat, Harrat Khaibar, Harrat Itnain, and these three are between Mecca, which is just south of Harrat Rahat, Medina, which is between the two, and then the Nefut Desert, which is in the north. So it's also called the MMN, Mecca Medina Nefut line. And it's more or less north-south, which is in a different orientation than the Red Sea. This one has been active since about 10 million years ago, starting with Harrat Rahat. And this is the one where we had this eruption in 1256. And we have a lot of different rock types here, from basalt to trachyte, different types of vents as well. And one thing to note is that from the south to the north, the eruptions get younger. And then the other thing, that the youngest one was 800 years ago. Then the areas in Khaibar and Itnain are also showing a lot of different compositions. And this is a place known as the Black and White volcanoes, which has been sort of, so it's not an official geopark in terms of, so it's not an UNESCO park, but there are some signs put up that there is a geopark, Black and White volcanoes. They did some attempts on tourism, not sure how successful it is. Another interesting thing of this area is that there's lots of archaeological like rock cycles present in this place. So it's something which also is of historical relevance. Harrat Lunayyir is very similar as Harrat Khyber, but it's much less studied. Computer is not so fast in moving forward. Okay, then in the north, there are several fields. One of the largest Harrat fields actually is completely in the north. Here I just have the Saudi part, but it goes into Jordan and into Syria as well. So that's actually the largest field. That one, again, has more basalts. And then there are the slightly smaller fields, Uarit and Hutaima. And the interesting part of these three fields is that they're not really on the shield, which I presented in the start, but they are sort of at the edge of the shield, and they're more on top of this younger sandstones, Paleozoic, Mesozoic. So in the images, you see some areas around Al-Ula, which is one of the historical sites in Saudi Arabia, also the only well-developed touristic site. And the basalt is sort of protecting the sandstone, which is underneath it. All right, and then finally, we'll zoom into Harrat Lunayyir, which is the topic of this project. So Harrat Lunayyir is actually a very young Harrat, only been active for around 0.6 million years. And that was the place where we had this direct intrusion in 2009. It's because it's not been active for a very long time, it's relatively small. And we are really on the shield here, and you see on the shape of the Harrat that the lavas are going into valleys, into wherever the lava was going, rather than having a thick layer of lavas which are just covering the whole area. So here you really have to go in between the shield rocks to find the lavas. And this location is also known locally as the Black Sands. People like to go there for camping. It is a place that people know, but most people don't realize it's actually a volcano, and that the black sand is not sand as the normal way that we understand sand, but that it's volcanic material. And the sand is coming from relatively explosive material, phreatic magmatic, that's forming these nice cones or black dunes that we have there. Yes, and with that, I want to sort of welcome you to the Saudi side and to the Harrats, and just to show a little bit on the beauty of these places. I have here a few photos to give you an impression why we think it's such an amazing place to actually study volcanic processes, and also why we think that geoheritage of this location is very important. And with that, I finish and take any questions, if there are any.
Yeah, if you've got any question, please. I enjoy why Frog is here. I don't know if you've got any question online.
Is there any similar volcanism on the Sudan side of the Red Sea, or is it just limited on the Saudi side?
It's on the Saudi side. So there's definitely nothing similar. It's a bit unclear. At some point, people tell me like, oh yeah, there are some volcanoes there too, but I never really found these volcanoes. So there's definitely nothing in this scale or anything similar on the other side.
Yes, please.
Probably not needed at the moment, but are there any plans for geothermal energy in the future?
Can you just repeat the question, just in case it's not?
Okay. The question was if there's any plans for geothermal energy. So these are monogenetic. We can discuss the term, but it's volcanoes that don't have a big magma chamber that is constantly active. There seems to be something maybe at that, but it's not very clear that they have a very high heat flow. So there are thoughts on geothermal energy in general in Saudi Arabia, but it's probably more relevant to look at the rift area or on the eastern side, because there's higher heat flow than related to the Harrats themselves, because the shield is just so thick that it's not really relevant for any geothermal.
I was just curious about the trace element signature of this things. What's it, an alkaline trend or?
Yeah, so this is a pretty normal alkaline interplate type volcanism. So in that respect, it speaks for kind of a plume source. Apart from that, we don't really have a plume. So it's the trace element signature more likely comes from having low degrees of deeper melt rather than that we really have a hotspot being present.
Any carbonatates?
No, nothing. So it's a normal alkaline type of rocks. It's not super alkaline or anything in that direction. More exotic.
Yeah, there are people raising their hands. Okay.
Right
So
there.
yeah, they're here. Let's see if I'll just stop sharing because if I can. Okay. And so where are the hands?
No, here's
Oh,
Carolee
okay.
has a hand.
Oh, Carolee, yeah, you can unmute yourself and please go ahead.
Hi, everyone. Yeah, just to answer for the question before about the Sudanese side and the African side. Yes, there are similar volcanoes in Sudan, like the Meidop Hills, a very typical trahite, basalt-dominated things. It's almost like a compressed version of the Harrat Khyber, so beautiful lava domes, mark craters stacked on each other and lava fields and so on. And there are also smaller ones. And even if you go more to the north, there are from the Eocene, from the wide desert in Egypt, more about maybe 400 kilometers from the coast, there are small Eocene, Oligocene, basaltic blocks, former volcanoes. And of course, there's a Cairo volcanic field, which is very close, just the other side of Sinai Peninsula. So there are scattered, but not as extensive lava field dominated fields exist in the African side. So we don't know that this is a result of the combination of erosion and other surface processes and just a removal, or just really that reflection that the main part of the volcanism is in the eastern side. And of course, there is Eritrea, Djibouti, and Afar, which is more in the south. Thank you.
Thank you. There is still a raised hand, is that so? I think you can unraise your hand then. Okay, so I guess, thank you. Okay, I think
Yes,
for now it's
we
okay.
can.
We still have a discussion later this morning, so if other questions come to mind, we can cover them later. I think, Carolee, you can share your screen.
Yes, thank you, David. So welcome, everyone. Unfortunately, I can't be there because of this awkward situation that my flight was just a couple of hours before I was ready to go to the airport canceled, and everything is canceled for a while. But I'm very optimistic that as David outlined, this project has a huge potential, and I'm pretty sure that it will really provide something very extraordinary things in the future. Can you see my screen in a full glory?
Yes, we can.
Oh,
So yeah, well, we'll turn down a little bit the light here. Otherwise, I think it's good enough. It's really hard actually to manage Teams better than this. I think it's good enough for us to see. Good.
yeah, okay. Thank you very much. So again, thank you everyone to turn up in this launching event, which I think is very important. I'm Karo Nemet. I'm working at the moment in the Saudi Geological Survey as a geo-consultant in the way. I have also other positions in Hungary, New Zealand, and also in Italy as well. And I'm also running a small non-profit organization in New Zealand called the Geoconservation trust, which focusing mostly from the Southwest Pacific Geo-heritage and geodiversity studies, but we are expanding slowly and just enjoying what we are doing. So in this morning, I will provide a little bit of overview about the geoheritage and natural hazard context, especially from the Saudi Harrat's perspective. You already heard from Froike that the Harrats are basically traditionally referring to black lava fields, aka some kind of a distributed volcanic field or monogenetic volcanic fields in general. So it's almost kind of a synonym, not really exactly a synonym between lava fields and monogenetic volcanic fields, but we can use this term exchange, kind of a inter-exchange perspective as well. So I start this presentation from the big picture and putting actually the geoheritage from the broader natural hazard context. What does this mean? Okay, now I try to, okay. First, I just provide few slides with lots of text. I'm not really reading all of them. That really I find important to actually putting some kind of a definition list here, what we mean about natural hazards and geohazards. Often the two things are used synonymly, but actually they're not really, because the natural hazards is a much broader kind of concept for anything which threaten any kind of communities, human communities, societies, and so on. With the geohazards is definitely focusing on the geological and the geomorphological processes in general. So in this way, the natural hazards usually contain all those hazards which are associated with meteorological hazards or any kind of meteorology-induced or climate-induced kind of hazards as well, even including forest fire and so on, while geohazards are strictly focusing on the geological and geomorphological aspects. We also have to say that the hazard is defined as an event. It's an event which usually have a negative connotation. It's also very important to appreciate this concept because it means that hazards in general treated as something which is very bad for the society. Therefore, communicating to the community about hazards is usually have lots of societal kind of issues that you have to sort out. As rapid the hazard, as destructive, or as frequently the hazard may occur in one region, as difficult actually this communication, because the collective memory in the society about one hazard type or hazard event often stay in the memory of the collectives for a while, and it's difficult to actually open discussion, especially proposing that those hazards and the results of specific hazards have some kind of a heritage value. This is a very fine example we just published with my Moroccan students about the 2023 great earthquake which destroyed Marrakesh. That actually, from geoheritage perspective, there are amazing new landforms generated by that earthquake. But still, after a few years after this event, it's very difficult to actually go to the community and actually convincing small villages that somehow need to protect few of those sites, because those are the messengers of some past destructive events, and if we preserve them, conserve them, we can learn something from them. So if we opening this discussion a little bit further, we also have to looking at the hazard, risk, vulnerability, and resilience as a four-legged kind of a conceptual framework, where obviously in the field of natural hazards and disaster risk reduction research, risk is the most defined as the interaction between the hazard and the vulnerability of the exposed system or element, including the probability of the hazard occurring. What does this mean? It sounds kind of complicated and complex. It's meaning that basically somehow, if we really want to have a effective resilience, basically developing a society which responding effectively and successfully for any kind of hazard, we have to understand first basically what type of hazard this society can be faced with, what's the risk that the society actually really exposed to that, looking at what's the vulnerability what we are dealing with, basically how vulnerable on the society for those concepts, and developing a resilience problem. Of course, the hazard is probably the most geologically defined aspects of this conceptual framework. The hazard is what the geologists usually ask, can define very well in a volcanic context, for instance, eruption styles, eruption intensity, and so on. These are the key input parameters what we are dealing with. While the risk is basically what kind of impact those hazards could have on a society. And then if we're looking at, how that certain society, let's say a Bedouin village community somewhere in the Harrats would respond against those challenges versus, let's say, an urban community. Then we have to design the pathway, how to do it, and that's basically the resilience. The resilience also something what we deal with, how the society would, let's say, able to cope with certain stress situation, which is already the cross line or borderline between natural science and social sciences. Some very interesting things what you can find out, there is a kind of a natural hazard classification scheme with the Global Facility for Disaster Reduction and Recovery organization, which is a very nice summary where you can see individual countries, what are the main hazard types that we can actually looking at, and what those intensity or hazard appetite for the specific country. They actually distinguish 11 types of hazard, categorized as geological and geomorphological hazards, including floods, earthquakes, landslides, tsunamis, and volcanoes. Very interesting that in this framework, essentially, Saudi Arabia, when you're looking Saudi Arabia, the volcanic hazard is one of the #1 hazard, basically in the top 3. In certain aspects, the #1, other aspect #2 is dependent on which angle we are looking at. So the volcanic hazard is actually a very significant, is ahead of the earthquakes, probably in the same weight like landslides. This is rather interesting because, on the other hand, what we see that the spending of hazard mitigation is extremely biased toward the earthquake hazard management. Neither the landslide, tsunamis, or volcanoes having such a level of support actually to do, which might change now after this highly goopy eruption in Ethiopia, when suddenly we realized that actually Saudi Arabia is vulnerable for those external hazards as well. So the natural hazard types, if you really want to have this in context, in the second edition of the book Geo-heritage, which edited by Reinhard and Brilla, first time they asked a specific chapter where the natural hazard connected somehow from the Geo-heritage perspective, and in this chapter what I prepared summarized basically the likely hazard type, and you see on the geological hazard, including earthquakes, landslides, tsunamis, rockfalls, and so on, or earthquake-induced hazards. The volcanoes are a very specific bunch of hazards what we can see, and you can see the manifestation from ashfall to laharic events to different lava flows and dome formation. And you can see that what is the geo-heritage implication for that, what you can see those hazards actually manifesting in a rock, exposed rock, for instance, different type of lava flows, surface textures, morphostructural elements, which are very relevant for the Saudi Harrats. You can see that in this natural hazard type, the hydrological hazards and meteorological hazards are treated with differently. The hydrological and meteorological hazards are many way from the volcanic perspective, can be looked as a cascading hazard types. For instance, when you have an eruption and the lava flow blocking some kind of a fluvial networks, that can generate flooding by damping basically the outflow from the system, or blocking the free passage of some volcaniclastic flows from the system, generating essentially sudden outburst kind of event. Of course, in Saudi Arabia, those kind of events are not so critical because the rainfall is very low, but especially in the Harrat Lunayyir area, in many of my field visits and works, maybe 3 times, I experienced a very intensive rainfall where essentially secondary lahars were running through the highways. So actually, those kind of hazards also exist even here. Meteorological hazards, for instance, cyclones and water scarcity, the typical kind of aspects. And of course, you can make this natural hazards a little bit more complex from the fire, forest, bushfire kind of hazards, which is in a volcanic context is a relatively common kind of hazard, especially in a hot climate like Saudi Arabia. Then we can, looking at the geohazards specifically from a different angle and classify them as rapid and slow type of geohazard. Rapid geohazards, for instance, essentially a sedimentary mud flow. What's this mean, rapid? It means that basically front of our eyes can happen a sedimentary mud flow crossing a road or a landslide actually breaking the wall of the large cliffs, and of course volcanic eruption, because a typical ash fall which providing and producing tephra successions, what we can use for tephra chronology, can accumulate within hours from the start of the eruption. Then we have the slow geohazards, and this has also excuse me, many volcanological kind of aspects. For instance, caldera development. It's probably we are not facing in a large-scale sense of stricto caldera systems in the area, but large mark crater formation, for instance, actually can be ongoing long after the formation of the mark crater itself. What we've seen in the Harrat volcanic field in the northeast of Saudi Arabia, where the mark crater is still actually subsiding and forcing basically farming to be evacuated and so on. Very similar to volcanic geothermal activities that, as Roike mentioned, that we don't have those kind of volcanic induced geothermal systems, but still residual heat can release some heat in certain areas, and that's actually a slow ongoing hazard what we need to deal with. So then what is the volcanic geoheritage? If you want to read this, is an open access book. In this book, there is a specific chapter about volcanic geoheritage where I try to summarize basically how the volcanic geoheritage elements can be classified and distinguished from geocultural elements and some additional elements. You really can see that from the volcanic geoheritage perspective, their elements require some kind of a defined spatio-temporal scale of the volcanic elements itself, where the most and the best concept is applied. What does this mean? This means that when we are looking at, for instance, our volcanoes, we have lots of small scoria considered in Saudi Arabia. If we really want to identify one of which are the real geosites which are good for, let's say, geotourism, geoeducation, conservation, and so on, we should somehow focusing in a comparative manner to the most and the best. This is, of course, very easy to say, very difficult to do, especially when you have lots of things to deal with. So how you can actually do this? In the other side of the diagram, you really can see this framework, how the geoheritage element can be translated to volcanic geoheritage site, defining some sort of volcanic geodiversity and all the additional parts which may all together forming a strong case that yes, this is the site what I can nominate and list in an inventory as a volcanic geoheritage site. Then this is where the volcanology come in, or general the geology, that in a volcanic context we can look textural and process dominated features. So there are sites which are texturally, let's say from a volcanic province perspective, volcanic landform perspective are unique, the best and the most. And there are sites which are from the process perspective. What does this mean? For instance, volcanic landform, you see from Roike lectures, a beautiful white mountains. You can see here, silicic tuff rings exist in Harrat Khyber, absolute #1 in the world. But you can also go to some site, for instance, in the Harrat Lunayyir, where you can see probably the best possible pyroclastic density current outcrops exposed there as probably the most and the best, not only in a regional scale, but also in a global scale. So then the volcanic geoheritage can be looked at from the volcanogeology perspective, let's say from the small versus large volume volcanism, volcanic eruptions type perspective, intensity perspective, volcano type perspective, and associated process perspective. And of course, you can systemize this in this little cartoon showing the geotectonic situation, which could be one aspect. Of course, you can ask that, yeah, it's again very trivial what I'm saying about it, but when you try to do it, and this is one of the biggest problem actually with inventory building for volcanic geosite recognition, that most of the people actually comparing pears with apples or orange with bananas, but not really looking at in a context, you know, for specific places from volcanogeology perspective of a volcanic system. What does this mean? And what's the relationship of this to our project here and what we will focus on? If we are looking at, for instance, the volcano sedimentary system from the core of the volcano, any type of volcano, to the distal part of the fan and also the sedimentary system, we can always identify where we are in this volcanic system, regardless that we are looking at polygenetic large volcanoes or small volcanoes. And we always need to somehow find analogies for those areas to be able to compare what kind of uniqueness best and most exist on those areas. And this is what this project probably try to aim to actually systematize and do it. So, pristine volcanic landscapes of Arabia is a perfect site when the volcanic landscape and the volcanogeology could be used for identifying volcanic processes and somehow communicate that. I'm not really going into this idea. Freuke already outlined the location of the Harrat. Here I just separated 18, but as Freuke also mentioned, there are many ways, and even within the one large like Harrat Rahat, at least 4 sub-volcanic fields can be recognized. So actually the boundary and the recognition, that's a scientific question itself, which not really addressed adequately yet. In other hand, from the morphological perspective, when you see this is from the Harrat Lunayyir, where our project will go, look at this beautiful sedimentary system when a quaternary aeolian fluvial system interacting with the dust, volcanic sustained dust deposition with the normal surface processes, lava flows, and the cone itself, and another cone in the background, in an extremely rugged surface which is structurally controlled. So in this pristine volcanic landscape, we can identify many features which are characteristics and typical for the volcanic field, and probably able to connect that to specific volcanic hazards. So, the first time I arrived to Saudi Arabia, about 15 years ago, I worked with Professor Rashad Mufti from the KU in Jeddah, and we started actually to discover the potential to using and identifying the volcanic features for volcanic fields, specifically for the Harrat al-Medina next to Medina city, where we were able to say, or we can decided to distinct volcanic zones under precinct concept, where we can see some very specific geological, volcanogeological features which can be connected to the hazard. And we see these 3, maybe 4 areas what we find and conceptualized and published in this paper in the Geo-heritage 2015, to actually using those opportunities to somehow disseminate the hazard information. What does this mean? You can design, for instance, geotrials if you actually can link certain geological site, volcanogeological site, like a steep lava spatter cone here, which is one of the steepest in the world in this way, through dedicated geotrial developments. So it means that you're actually walking through of those systems, you're checking those sites, and again, the best and most within this framework, you can recognize those areas like lava tubes or cone escarpments or certain skyline event or spatter cones, which are really characteristic and good for this way. In these recent years, we have lots of technological development, including drone and virtual reality applications, that obviously not everybody will walk up to this cone, despite that it's about 20 kilometers downtown Medina. You could easily drive there and walk in there, but in 54 degrees is quite a challenging job to do, and probably not with after having kids with you and so on. So we can also using those recorded features to actually showing to through certain communication channels to the visitation or the visitors what you actually can see and how you envision a crater of a volcano which is only less than 800 years old, and you see beautiful fissures which are showing that there is a fissure aligned vent system fed these volcanoes. You can see in this other picture, which is also raising the point that probably these volcanoes behave very similar like what you see in these days in Iceland. Then you can go into the Harrats, for instance, this area, and you can see processes which telling you that there are pit crater formations, stable lava storage places where suddenly you emptying a lava flow and the lava actually make a void, everything collapsing, and or you can see some kind of an intrusions which seemingly popping through of this very unstable, dynamic, growing volcanic system which feeding lava flows in the side. Then you actually can see in the nearby Medina, again about 1 hour drive from downtown, you can enter to an absolutely untouched region where you can see explosion craters with clear areas where you can see individual so-called monogenetic driven pyroclastic density currents with trachytic condition, which probably runs through this entire environment, reaching about 5 kilometers from its source, like from the Gura 2 point here to the other where the block and ash flow run out marked with a little arrow, giving us a perfect opportunity to use this and preserve this area as a memento to show what is the power and the scale of a pyroclastic density current, a block and ash flow in this perspective, capable if similar eruption would take place. Why is it important? Because this area, for instance, in the Harrat, northern Harrat or Harrat Medina region, was or suspected to be one of the youngest eruption about 4,500 years ago, according to the USGS geological mapping, producing a typical Mont Pelée type of telescope type of lava dome complex, multiple complex, and a beautiful block and ash fan, which actually coming down to the nearby valleys, reaching about 10-12 kilometer runout distance. In this area, you see in this image, these beautiful arrows marking a beautiful valley, very similar like what you could see only in the middle Anatolia, in the Melendis Canyon, and those large ignimbrate areas, with the difference that this actually fed by a singular, maybe 2 explosive or 3 explosive phase lava dome explosion and accumulation of 2, maybe 3 pyroclastic density current units, perfectly exposed in this nearly 4 or 5 kilometer long valley, a perfect geosize to actually show to the people what's the power of the such processes. Then you can actually systematize basically the volcanic process based on volcanogeology to actually providing some kind of a manual how a geopark could be built up. So then we're reaching the point that the geoheritage apparently can be used as a tool for efficient geohazard resilient education. And then we have lots of reasons to actually explore this, and I'm very happy to have this project approved, and UK experts, Saudi experts, global experts could work together on this, because, for instance, in the Harrat El Medina, for instance, there are many evidences of fissure vents. You see, even in these old maps, sketched maps, which is geo-referenced and overlaid by new observations, showing very nice the recognition of fissures. So it's in one of the main feelings or the main features of this type of volcanism here in the Harrat region, that the vents and the volcanism was fissure controlled. What does this mean and why is it important? If we are going to the Harrat Lunayyir in 2009, we have this fissure, which was about 15-20 kilometer long, opening, and no lava came up, but all the other vents, and you see I marked the vents, identified vent locations, and you see the seismicity in since 2007 to today, about nearly 20,000 seismic events recorded. You can really see a very distinct orientation, which happened to be the same like in this surface model, hillshade model. You really can see the orientation of the rugged basement, the neoproterozoic basement, and how the lava filling those areas. And why is it important? Because in this area, there's a strong development for tourism. This area was targeted as a primary area. This area was as a potential future areas. Now they modified partially because of our study in these areas that maybe should not really build a hotel in the crater of the youngest known eruption site, but pretty much the area is actually like this and is under strong development pressure. So it means that somehow, if we really want to let the tourists going and be responsible for hazard perspective, we need to actually invest somehow energy, time, and funds, how actually all these things can form basically the core of hazard education and resilience for volcanic hazard. For instance, in the city of Al Medina, there are small cones, 4 cones, what they call the Alduaita cones, basically forming as 1.2 kilometer long alignment, beautiful cones, all of them very small. You see, this is 250 meters, so it's really tiny cones. This is a digger and one of share. Very interestingly, in this cone, we just find the most obvious and amazing evidences for phreatomagmatic explosive phases in the initial stage and the opening of these areas. So while the quarrying actually gradually opened up new outcrops, but also removing these small cones, taking away the opportunity to have this for the future, to argue that yes, this beside that the Medina region largely magmatically explosive or explosive volcanism what we have to deal with, but surprise, surprise, in the small volcanoes, probably because very small volume of magma was interacted with the external water, created an explosive eruption. So the alarming point is that in 2004, this was the cone, one of the cone looked like this, pretty much intact, nothing. In 2023, you see basically half of them are gone and actually going and getting away. This is really very unfortunate for volcanic hazard perspective. This is a diagram from 2013, based on a 2013 LiDAR survey. You see beautiful crater, double crater. You see the tough ring here. This tough ring is essentially gone. This is this area. And basically we are losing information. We're losing essentially all the things. So this highlights the need for effective geoconservation to rescue this kind of sites and essentially using them for volcanic hazard resilience development. Other example, this beautiful large cone, which was in 2013 completely intact. You see nothing changed. This is the same markers and the same point. But essentially in 2025, you see that significant site of the volcano gone. This was 2013, absolutely pristine environment with a beautiful mafic sedimentary, volcaniclastic sedimentary system associated with it. In the city of Medina, where we probably need the most preservation of these sites because we want, that's the most people live, cones gradually disappearing. And as Freuke pointed out, that even the 1256 eruption sites has a new sections, new cities, new parts, which actually moving through the modern lava flows, completely taking away entire cones like this. This cone was removed 2013, 2021, nothing left there, new development. Besides that, if you look at this chain, is a clear and absolutely graphic evidence of fissure type of eruption, just like what we've seen in Iceland recently. So this could have been or should have been preserved for the future, because after the development, nobody will remember what is there, what was there, and what we should actually face for if new volcanic eruption take place. And just like finishing the talk, of course, I'm understanding the urbanization need, the development need, and the construction roads and other kind of things. And obviously the scoria, especially the podzolium, which is a highly vesicular, light, basaltic, glossy ash and lapilli, very, very suitable to making basalt wool for insulation, filtration, and so on. So it's a high economic value, so it's very good, okay. But once something is removed and it's decommissioned, probably these sites could be used very well for geoeducation, because, for instance, in this site, if this site is cleaned and maintained, can be used, for instance, to understand basaltic fall deposition. Immediate remobilization, of course, ash and lapilli in the flank of a scoria cone. So many things can be actually said and used for that. So altogether, and in summary, I would say that the Saudi Harrats are really perfect places for using them by identification of specific volcanogeology aspects of them for geoeducation. And if we have an effective geoconservation offer, very likely these sites could be well used for geotourism as well. So actually, this is a multitude of and conceptual framework, especially if we would work together with local communities and stakeholders, how to do this, how to translate this complex information. We all can succeed, and the society would definitely benefit from all those things. So just an advertisement, if you really want to listen more about the volcano geology, volcano conservation or geoconservation perspective, there will be a conference in Sopron, Hungary in the end of May. The registration are still open, where you also will have a chance to look slightly older, but similar type of alkaline volcanic fields. And another kind of things, there are many journals where you actually can present online and in a written way about this concept and very vivid and developing perspective of the connection between geohazard, natural hazards, and volcanology, volcanogeology. Thank you.
Thank you, Harald.
Okay, I stop the sharing. Oh,
Yeah,
30 minutes.
Full size now. Yes, very good. Thank you. I don't know if there is any question, any comments. I don't necessarily have a lot of questions. I was just wondering what's happening with the basically glassy basaltic material that's removed from the cones. I guess some of the cones are removed because space is needed to build new houses and roads and infrastructures, but there are quarries. What are they doing with the materials?
Well, obviously, you're right. One of them is really space, making space and so on. But the scoria, especially this vesicular kind of light scoria, is a very light material. It's very good for groundwater regulation. So you can use it for pipes, filtration systems as a natural material. It's really very, very good material. It's very robust, it's not really breaking apart like it's not third to be clay mineral very quickly. So it's a very good material. The other thing is that this high quality they call podzolian, they actually using them for they call basalt wool. It means that because it's high vesicular, very light, you can put into some industrial furnaces, you can burn it, melt it, and after you can make like what is this? This sugar candy. I don't know, in my childhood, I loved, when they put the sugar, there's a spinning machine and became like this, like a spider web, like a froth. I don't know in English. Yeah. Cotton candy or something like this, yeah. So you do exactly the same, but with basalt. For instance, in Korea, they're using that, melting those podzolian and making fiber out of this, micron-size fiber, and then making basically like when you are making clothes, those fibers, and then they sewing, creating mats. I have a basaltic mats made out from this scoria, which can handle over 2000 degrees temperature. You can put in the lab or you just put on a table, hot pot, very light, very thin. So it's very expensive. So partially in Saudi Arabia, they're doing this, and I think they're exporting it probably back to Germany, at least. That was what I find. But I don't know where the plants which doing it, but they done the same things. Very expensive. So it's really very good material.
Thank you. James, do you have a question?
Yeah, this Pozzolian pipe you were talking about, is that named after Pozzoli in the Flagrant Fields in Italy? Is it the same spelling as that?
Yeah, yes. Yes, I mean, the original location where they have, it's a little bit more phreatomagmatic, it's a little bit more glossy in a sense, but the same very light, frothy kind of things, yes.
Thank you. So You have a question?
Just a quick one.
Yeah.
I was wondering, how many of the geosites you've looked at already actually have quite a lot of archaeological significance? Because just culturally, like a lot of the places you mentioned, they are a really big part of Saudi folklore. So if you look at Khaybar, for example, where the latest eruption was, you know, that's a place of religious significance in Islam from the time of the Prophet. And if you go further north, like Falca mentioned, you know, there's a lot of archaeology in the northwestern part. So I was just wondering, what's, you know, how much intersection is there between anthropology, archaeology, and geosite development?
You just touched the sweet point. It's amazing. That's one of my kind of a professional hobby to expand, you know, things. I'm always interested in the geoarchaeology, archaeology, and history in this way. You are perfectly right. I mean, I'm partially in working with colleagues, you know, to explore and catalog all those things. And you are absolutely right. There are enormous number of archaeological sites. Even I myself, I recorded really hundreds which not been known before, telling us that there are entire cities, entire strange monuments. I wouldn't say like pyramids, but some kind of a pyramidal kind of a structures, which probably used flat stones, which might have been polished for steps in areas where you just don't think. And actually also been connected with archaeologists that the mainstream archaeology and the confirmed ages of of those features are maybe 7,000 to 11,000 years. But I was meeting with a archaeologist group where the lady just suddenly said she would not be surprised if it would be definitely Paleolithic. So we talk about over 100,000 of, definitely over 50,000 years old features. So I also have tools and other kind of things. They are all over the show, and it's not just like a bunch of rocks or kind of a early manufactured stone tools, but also like rocks which are somehow arranged to some pattern, and the pattern are not obviously, in my opinion, really being used, in my opinion, for some kind of a hunting or something. It's more like spiritual kind of context, because they are very much located in very nice areas. The other things of these features, because their abundance, it means that we need to looking at the pluvial periods of Arabia. You know, the concept of green Arabia, about 3,000, 3,500, 7,000, 11, 14, 17, 23, and so on. So there are pluvial periods, and those periods, very likely these areas between the lava flows, especially, these lava flows must have blocked entire valleys where you created, after rainy or humid periods, lakes with 2-3 meter depths, and you see the lake deposits. So that's why in our research in this project, I really hope with David we can do something in provenance analysis, finding some kind of things, because I see with the morphologically the evidences are there. We need to look for it. Yeah, thank you for a very good question.
Thanks a lot. So we are really off track regarding the time. I think we still probably need a short break. We'll take like 5-ish minutes, 10 minutes. Okay, Katie says 10 minutes. So we will reconvene in 10 minutes, which is 20 to 11 UK time. Thank you. So first of all, I've realized I probably didn't introduce myself properly at the beginning of this workshop, which is the obvious thing to forget about. So you will have understood, I'm David Brooks. I'm a senior lecturer at Cardiff University, still part of the School of Earth and Environmental Sciences and Really Changes in the university. That's the reason why I say it this way. What am I in terms of researcher? I'm probably many things. I guess my specialty is to not specialize. And I don't only mean this as a joke, I think it's an actual thing, but I'm basically a field geologist interested in volcanosedimentary environments, and I've used geochemistry as one of my main tools to address a range of questions. This is really my academic background. But before I started working in academia, I was working in museums of natural history in Switzerland about 20 years ago. And this is how actually I got acquainted with the notion of geoheritage. At this time, it was still the early day of geoheritage, but I learned it through doing, not through theory or not through research. It was just really a practitioner point of view. And this has basically stuck with me throughout the years as I grew to be a researcher. And I've been working since then as a hobby or as a consulting geologist in some smaller projects related to geoheritage or geotourism, sometimes also doing some small consultancy for UNESCO-related organizations or just UNESCO. So my talk will be about what is geoheritage, and it's a simple question with 3 words, which has many, many possible answers. And I'll try to show you why that is. So this landscape here is a Picus-D from nearby Barno Bricheño National Park. It's part of the Forest Vow Geopark. We're going to be very close to it in a couple of days. We'll not be standing on that very mountain, unfortunately, but we'll be next valley and we'll visit the people of the geopark there. So what is geoheritage? If you ask the question to anyone vaguely aware of the notion, you will probably get the idea that it's a site with interesting geology, that the information is provided that explains the geology. So typically, here is an example from England, where you've got a display, a small sign showing actually the information related to this beautiful outcrop here. Very often you have some, if you're lucky, if you've got the funding, if it's a good, let's say, site or well maintained, you will have some conservation measures. So here you can see there is a fence. I'm not sure the fence is here because of that geoheritage features, that geosite. But definitely you get some fence here. It's mostly for safety of visitors, I suppose. And you can have facilitated access. And very often people also will come up with the idea that you have some conservation measures. And this is something, I guess, this notion of geoheritage is definitely something that was well covered in previous talk by Carolee. And so what I will show you is that actually it could be more than this, far more than this. And not in a diminutive way relative to what has been said so far, but in more like a positive way to say we can also use geoheritage as a very powerful tool for communication. So let's have a look at this. So I'll start just by a few just general context slides. So historically, geoheritage has a meaning and it's been linked to geoconservation. And the UK has played an important historical role in this, started a long time ago, almost probably close to 100 years ago. But in the UK, geoheritage has been historically linked to sites of special scientific interest, which are called SSSIs. And these sites, they're still active today, they're still managed. They come with a primary statutory designation for protecting important natural sites. So it's not only about geology, it's about anything that is related to the natural environment. And this is actually, it's a legal designation. So it is actually designated under the Wildlife and Countryside Act 1981. So at this stage, probably most people in Saudi Arabia are wondering why they're sitting here in this talk or listening to this talk. The thing is, in some places, there is some really strict regulation about protection, which my understanding, according to Carolee's talk, is perhaps not still well developed in some places in Saudi Arabia. There is also very often a disconnect between protection of biological features and geological features. Geological features obviously don't receive as much attention by regulation bodies in some places around the world compared to biological features. In Wales, there is a natural resource Wales, which is I don't know actually how to explain this in a few words, but it's kind of an institution of the government managing natural resources. This is the institution in charge of managing the SSSIs. But interestingly, and I don't think it's something that many people will know of, geology has played a defining role in the SSIs, or what would lead to the SSIs historically. As early as there was another act in 1949, the National Parks and Access to the Countryside Act. Geology was one of the pillars, the cornerstones that led to this designation eventually of SSIs. So even though geology nowadays is very often considered to be, you know, maybe less important than biological aspects or other natural aspects, historically, at least in the UK, it was a very important aspect, and it still is for many communities. So how do you define, how do you design an SSI? So a lot of this work was done in the 1970s to 1990s, and it was part of what's called the Geological Conservation Review, or GCR in the UK. And there were 4 main criteria used to select the SSIs, and they're very strict criteria. First one is the representativeness. So basically the question is the site a good example of a particular geological feature or period? And here I'm really focusing on the geology, but you could do the same for biology. Sometimes you can also have an SSI that will include both the geology and the biology and other elements. I think these are probably the most interesting SSIs. Then you get the extent and condition of your feature. Obviously, to make it an interesting site, you want things to be well preserved if you can, although sometimes having quarries can provide access to exposures, which is good for geology. It might also facilitate some biological processes. The rarity, SSIs, that's an important thing. SSIs tend to focus on things that are rare and therefore have this idea of value attached to them. Because it's rare, it might be actually valuable. And it's something that could be valuable nationally, but also internationally. And then the scientific value is also one of the important aspects of the designation of an SSI. So it would be for both research and education purpose. However, does the SSI designation really cover the whole breadth of what is a modern definition of geoheritage? So if I'm asking the question, it's probably because well, the answer is not quite. So SSIs do a few very good things, right? Protection, they really outline the value, scientific value of a site, and yeah, they address these criteria. But look at Forestwoud Geopark in nearby Cardiff. You've got this beautiful landscape. This is Geo-heritage. Does that work really in terms of SSI designation? Yeah, not quite. I mean, it's this landscape. Is it representative of Forestwoud? Yes, but there are other really nice areas that look, you know, pleasing to the eyes. Is it rare? I don't think it's like super rare, although you could argue that every site is unique and therefore it's kind of an element of rarity, but there are similar landscapes in the nearby mountains, extent, condition of geological exposures. Well, in this case, we're really not looking at an outcrop, so exposure of rocks. We're looking at the landscape, so I guess this doesn't really fit well. And scientific value for research and education, yeah, maybe there is some. I think there is more, in this case, value for education than research. But you can see Geoheritage can be much more than just the designation for SSIs. And this is what I will expand on for the rest of this relatively short talk on the idea of Geoheritage. So what is Geoheritage? I think a better definition, and that's one possible definition. There are many other possibilities to define Geoheritage. So it's geological and landscape features or sites that hold significant scientific, educational, cultural, aesthetic. So it's something could be very personal and, you know, vary between different people. Could be also ecological. So it's not because it's geo that it cannot be ecological. Value, and they are considered part of our natural heritage, right? So this is a shared kind of community definition. So it's a great concept. This definition is a great concept to basically foster the idea that you can tell stories about our shared natural heritage or the story of the earth. And therefore, if you adopt this definition, Geoheritage becomes a very powerful communication tool. So there is a narrative value of geoheritage that I think can foster collective benefits through knowledge exchange, like, for instance, addressing climate change, natural hazards, and local economics. And I will just illustrate this very briefly. This is a slide I prepared several months ago before we knew that this workshop would take place. So I think it's a good working hypothesis or good definition of geoheritage that you can take forward in many places. I've actually used this slide before in other places. I think it's a broad, inclusive definition of geoheritage. I'm not going to spend too much time on this, but I've just touched on the idea that, you know, geoheritage can be something that is shared among a community. In the UK, there is an active group, it's called Geoconservation UK, who's been helping manage geoheritage, not only from an SSI point of view. In fact, Geoconservation UK, I think, emerged, I might be corrected by some people in the room, but historically, this group of people came to be because the SSI designation was too strict. And some people were really interested in promoting geoheritage, and therefore they came together as a community. And this is something that is still going on in the UK, and I hope will be maintained and rejuvenated through the years. This is something that I believe other places like Saudi Arabia could benefit from. So now I'll just take you through a few examples of what is geoheritage, so very different examples in the context of this broad geoheritage definition. And I will use mostly Welsh examples. So if you go very close to Cardiff, you can go to a place called Barry, just a few kilometers away from here along the coast. You see these beautiful red beds. They are Triassic red beds, and they're deposited on basically Pangaea as it was starting to, or shortly before it was starting to break apart. And this is a terrestrial environment. It is actually a desert environment. And it's also covered in some places by dinosaur tracks. You get here a beautiful record of the earliest dinosaurs in the Triassic. And it's great. You can go there and you can see some of the tracks. It's an SSSI. So in this case, my overall definition of geoheritage meets the SSI designation. And it's attracted some attention regionally around Cardiff. That's here a BBC report. A few years ago, actually, a little girl from the area was walking around the coast and found an amazing example of a footprint, track of a dinosaur. So it was really good. And it attracted attention, and unfortunately, it also attracted unwanted attention. And some people, a few days later, decided to use a sledgehammer on the site for whatever reason, which is a bit silly, but it happened. So in this case, it shows that, you know, geoheritage is good. It's a shared value. Some people of the public can contribute to also maybe the enhancing the scientific research or consideration of a site, but equally sometimes attracting attention can be problematic, especially if you're looking at something really valuable like an SSI. So of course, geoconservation is important when you talk about geoheritage. Another way of considering geoheritage is, well, you don't have geoheritage on site. It's basically been relocated in a place where you showcase some elements of the geoheritage. And a very good example of that is a museum like the National Museum in Wales. So they've got a pretty good exhibit on the history, the geological history of Wales, and they've got some dinosaurs that are displayed there. So really exciting for the kids and the families. But you get also other more like technical things about, you know, formation of the solar system. It's really very long history of the formation of Wales. But and then you go through the different rock types that form also some of the landscapes around Cardiff, and you really go, it's a kind of a corridor setup, and you go through the different times of the evolution of Wales. So this is also geoheritage. You can also consider that the museum collections are a sort of geoheritage because they are here for the public benefit. You can access them, you can make requests to get some loans, maybe use some of the samples for some specific research in collaboration with the museum. And it's not limited to museums. You get national organizations, like in the UK, we've got the National Geological Repository. It is, in a way, Geo-heritage. And also internationally, you get really fantastic communities, like previously the International Ocean Drilling Program. So basically a group of international researchers working for several decades, drilling the seafloor all around the world. And then you've got core repositories. These cores, I would argue, are also a type of geo-heritage. So whenever there is some human activity, the geo-heritage can be perhaps damaged. So we had the examples of Caroline in the previous talk, but also it might sometimes, if you find the right partners, or if you get the right setup or ongoing collaboration in a country, perhaps you can also generate geo-heritage. And I'm mentioning here this example, which is not from Wales. I've done some work on the formation of the Isthmus of Panama. I worked with the Panama Canal before. And so it's a fantastic piece of geology there. There are some monogenetic volcanoes, which we identified with my research group here in Cardiff. We identify them. Well, they have been around for a long time, but it's all covered by jungle mostly. And you close to the Panama Canal, then you have the Panama City. So you don't have a lot of exposures. It's tropical, covered by forest vegetation, or it's covered by houses. What was really frustrating to me is that at some point they built new metro lines in the city, and while they were doing this, they started to do a lot of drilling, and they collected cores mostly for geotechnical, geoengineering aspects. And they looked at what they needed, and then they threw all the cores away. And I realized this too late. The project was nearing the end, and there had been no communication between the people running the metro projects and other local organizations like universities that could perhaps save a few of these cores. And the exposure is so limited there, is really sad. So it's a kind of a missed opportunity, which I like to mention, not because of my lasting frustration, but because I think it's just an example to show that sometimes you can generate geo-heritage, you can create repositories that could be then become really useful for a range of things. And sometimes it's really hard to know how perhaps the cores from Panama or the places could be used. The same apply, for instance, to the IODP example I just gave in my previous slide. To go back to some example of geo-heritage in Wales, something that's also linked to the geo-heritage is whatever cultural, and in particular here in Wales, industrial heritage you might have. This is linked to geology. As you know, Wales was one of the prominent places during the Industrial Revolution. You could argue that it started more or less here. It was related to the coal fields, so there was the coal, there was also production of iron. And it's been something really, really important as a nation here. This is an important piece of history. The coal mines, most of them are closed since then. So we're talking here about a history of 200 years, roughly. Well, 100 years and 50, maybe. But you can still visit some interesting sites related to this industrial heritage, and it is also a type of geo-heritage, and it has some UNESCO World Heritage label in different places here in Wales. Geo-heritage can also be something that you just, entertain people with. You take a group of people to different places which look nice, and you talk about the geology. So this is an interesting project that is also kind of Welsh-rooted that I had with GeoWorld Travel. So it's a small company of geotourism in Wales, led by James Cresswell, who's sitting in the room this morning. Thanks, James, for being here and for allowing me on this trip. So we designed this trip. I'm originally from Switzerland, and we had a tour in Switzerland. And essentially, we took some international tourists to different sites. So here we are. We've just had piled up a few rocks at the foot of the Matterhorn. And I was not talking about what the rocks are made of, although we had a little element of discussion about this. It was really showing how the rocks show the story of the formation of an ocean that used to be between Africa and Europe. And then everything just collided, and you form the mountains. And you're here sitting at the suture between Africa and Europe. You've got the Matterhorn, which has some continental element at the top, and then some ophiolitic ocean-derived elements at the bottom. And you can collect the rocks because the glaciers have retreated. And you can make up, or you can actually present a very interesting, dynamic story. And you can do this all around the world, including in Saudi Arabia. And it's something that's developing. It's developing for several reasons. And I'm not the best person to explain this, but I will just mention it as is it part of this workshop. There is that Saudi Arabia's Vision 2030, which is a big government project there, and it's fostered a range of activities. One of the ideas is to develop tourism. And there is also in the areas of the volcanic Harrats, there is that black sand tourism, which is now developing. So I think in the context of our project, this is something important to keep in mind, because some of the stakeholders could be companies in Saudi Arabia interested in geotourism. And we're interested in this because of the Geo-heritage link, and we need to communicate to people to really understand, to make them understand maybe some of the geohazards and so on, but just make them realize that they're living in an active volcanic environment, although it's not super active, admittedly. Back to Wales, we will visit very soon, in a couple of days, Forest Fawr UNESCO Global Geopark. So Global Geopark is something that has the UNESCO designation. A good definition is by Alan Boring, here basically talking to a group of people for the 20th anniversary of this geopark. It's a very old geopark. And a global geopark, according to him, is an area of particular geological interest. So talking here about geology, but under the UNESCO banner, you have local communities that have come together to protect their landscape and wildlife, so included wildlife in there as well, to celebrate the many links between different aspects of their natural and cultural heritage. So there is an idea of intangible heritage, stuff that you cannot see, you cannot feel, but you can share through stories, through legends, through myth, etc. And you can basically you can link to the wider world and share that with residents and visitors. So it's a very UNESCO-like definition. UNESCO global geoparks now are really found in many places around the world. You get hotspots, mostly in Europe and in Asia, a few developing sites in the Americas, not so much in the US because they've not adopted this designation yet. They've got their own natural park, national park designations. But you can see 2 dots in Saudi Arabia. Since last year, there are 2 UNESCO global geoparks there. So it's developing in Saudi Arabia. In Wales, we've got another geopark. It's in North Wales. It's called Geomon Geopark or Anglesey Geopark. It is a fantastic area for the geology. Here is an illustration of Llanwyn Island, where you get really fantastic Neoproterozoic accreted oceanic sequences. You can look at the seafloor on land. It's also a fantastic site for the culture. There is a story of Dwynwen saint, who's the saint patron of lovers in Wales. So she lived there in the 5th century. So it's a really long cultural heritage, long-lived cultural heritage. And so I had a PhD student in Cardiff working on the geology there because it's really interesting, scientifically speaking, but also we collaborated with the geopark, and my PhD student worked on developing a geotrail there. And of course, we presented the geology and the concept, but some cultural elements also can be included because of this connection to Welsh heritage culture. There are other ways to outline the value of Geo-heritage. So in this particular case of Anglesey, it's been done through the IUGS. I think Carolee will touch upon that in the forthcoming talk, so we'll not mention too much about this, but this is another way to valorize a site. An important thing that was done as part of the PhD project on Llanwyn Island was to characterize the value of the geoheritage. So the way you do this is you can use a framework of evaluation where you've got different things, and I don't have the time to really expand on that today, but for instance, there could be the educational value, could be scientific value, tourist value, etc. You get many different aspects, which we will discuss tomorrow in the field with the on-site participants. And then you can construct these radar figures, charts, and you can plot your different sites within your area and have a quick overview of the relative value of the different sites. And this is really good to help design some geo-trails. So this is one of the ways you can make the characterization of geosites. There are different approaches, and it's always evolving. I think we can take this approach and keep on developing it to include geohazard. And then we could basically adapt the work that's already been done in Harrat Lunayyir and expand it to include the geohazard component. But we should definitely include some cultural elements as well, because we need to communicate to people. And if we were to, for instance, design a trail or something, or work in collaboration with geotourists companies in Saudi Arabia, we need that kind of wow, factor. You want to excite, enthuse people to get your message across. So it's far beyond just science in itself. In Wales overall, we've got many opportunities to do this because, well, the landscape is pretty exciting, I think, especially when it's not raining. And the geology is also fantastic. There is a long history of studying the geology, and there is also a long history. So you get castles in a few places. You can make these links between the different aspects of geoheritage. We had a few projects over the years in university. There was a very good one a few years ago by a master's student who received actually a national prize for the quality of this work. So this is really working at the boundary between research and outreach, and you can involve young people in this. I think it works really well. You don't have to have like a fantastic landscape next door to do actual geoheritage promotion. In Cardiff, for instance, there has been some walks that have been designed by a local geological society to do urban geoheritage. So what is it? So it's basically you look at rocks. We could even do this in this building. I could guide you around and tell you a few things about rocks and the geological history of the area, and other things related to Wales, historic aspects. But you can basically use building stones to tell stories. And it's not about explaining what the rocks are to people that have no clue about geology. It's about using the rocks to tell a story that will make the people interested in the geology. And the way to do this, and I've done this a few times in Cardiff, and people typically are like, oh, you can't say that with rocks, and this is basically what you want to achieve. You want to get people in the mindset where they see value in the rocks after an interaction with them, whereas they were maybe not seeing as much value early on or before you met them. But in this case, you can just point at a rock on a house. You have this is again a Triassic, this is a conglomerate here, or breccia, deposited in a desert environment. And you can show them where Cardiff was at the time. So obviously the geography is not like that of today. You can mention that there was a supercontinent called Pangaea. You can also show them what was the environment like. You get artists that have been really good at, just showing in an exciting way what is the environment like. So it doesn't look like Wales today. And these things are not technically dinosaurs, but they're definitely strange looking animals. And, it's just it helps people see some interest in these rocks. You can also show more like an analog in the modern world of what Cardiff was looking like. It was looking pretty much like this. So this is in Nigeria. Actually, maybe Cardiff was looking a bit like some places in Saudi Arabia today. And you can still see that if you go just off Cardiff, you get a lot of red beds. We look at some of these things, not exactly these ones, but some of these things tomorrow along the Glamorgan Heritage Coast. So yeah, rocks can really link to a very powerful narrative. So what is geoheritage? Yeah, it is some features with scientific value, but also it can link to just the natural beauty of an environment. It can be also some area or features with intangible value like culture or history. And importantly, it's any feature that can promote a geo-narrative. And this is really important for communication. So I said before today, I was showing this slide and I said, this is not a good slide. This is how you design a project to get it funded. But in practice, I think the way to look at this sort of project is not to have these 3 steps with, you know something, you do some research, you produce something. I guess it's more this type of more organic take where you start with knowledge, you've got some questions, some challenges, and then you develop a framework. And in this case, I think in our project, the Geo-heritage framework can be really powerful. You can link it to the new research. And of course, this is a major component of our project, but it's not because it's major that it needs to be at the center from a structural organizational point of view. We can talk more about this with the rest of the research group this afternoon if you're interested in. But then you can create some benefits for stakeholders, and eventually you can also enhance community resilience. So, but I think the key word here is definitely the framework around geoheritage notion. So yeah, I think that's all I wanted to say with what is geoheritage presentation. So thank you for your attention. If you have any question, I'm happy to take them now, or we can maybe take them to the final discussion. Thank you. You have a question, Ricardo?
Through your project, you potentially would like to lay the foundations to create a geopark in Saudi Arabia?
Yeah. I mean, it's not technically part of the project. It's not being written down this way, but yes, in a way, it's already been done by Carolee and other people in the Saudi Geological Survey, and I'm sure probably other people. There's been a lot of already geosite characterization. But if the idea is to lead to UNESCO Global Geopark, then I think more elements like archaeology and all associated, maybe cultural intangible aspects need to be considered as well. When you want to validate a UNESCO Global Geopark, I think you have to answer 111 questions or so. So yeah, it's the key message here is if you want to develop this type of geopark, you need to have a very broad mind. You need to be very inclusive in your approach. It's much more than just geology, which in itself is already a lot, but that's the scope of the UNESCO accreditation. James.
Yeah, thank you for mentioning that. I was just thinking as well, this on the different designations that recognise the geoheritage. There are also national geoparks.
Yeah.
We have a national geopark here in Wales, part of Wales Geopark recently established. But I was also thinking national parks as well.
Yeah.
Now, in some parts of Wales, like the US,
Yeah.
a lot of national parks like Grand Canyon or Petrified Forest, it's still a geology in that wide national park. So that's just another one to perhaps they didn't set up a national park purely because of the geology, but really the geology is the underlying reason.
Absolutely. Yeah. I mean, there is more than just UNESCO Global Geoparks, and big parts of Africa were empty in terms of this UNESCO designation, but they're super interesting, and a lot of people go there for tourism anyway. So yeah, absolutely. Yeah. All right. So then, if there is no other question, thank you. I think, Carolee, you're giving the last presentation of this morning before we have the discussion.
Okay, thank you very much, David. was fantastic lecture, and I would say it's just like a perfect things to actually start my presentation here. Can you see my presentation?
Yes, thank you.
Okay. So in this last or follow-up presentation, I tried to summarize the geodiversity and their connections to the Saudi Harrats. I put a little bit of subtitle here calling the new Geo-heritage research initiative by the Saudi Geological Survey aims to serve as the national guardian of the abiotic natural values of the Kingdom of Saudi Arabia. So this little subtitle is actually reflecting that within the kingdom, the Saudi Geological Survey start to recognize the opportunity to actually acting as a knowledge holder of the geological or abiotic natural values within the kingdom, which is actually a very good move because it's somehow this is aligned pretty much with like the Spanish Geological Survey, how they actually do managing this kind of things. Of course, giving a presentation about geodiversity or in geoheritage in general in the United Kingdom or in Wales, it's really challenging because one of the birthplaces, as David demonstrated in his presentation, dating back in the early 1990s, when all these fundamental conservation-driven concepts actually been established and propagated through the world, through the continental Europe and so on and beyond. I also have to mention here my co-authors, the very great team from the Geological Survey, like Rashad Mufti, Turkish Ali, Nasser Jadali, Iyad Zalmun, Jahia Muhaveref, Mahmoud Ashor, and Abdurrahman Savaya, with whom we actually started in the last 4 years to exploring geodiversity in general intensively and try to connecting what, especially from the volcanic geoheritage perspective, can be done within the kingdom and how they can be connected to the global movements of this progression. Okay, now I try to, okay. So there's one statement, and I think this came out very well from David, one of David's slides, that yeah, the Vision 2030 is one of the huge and very grandiose vision of Saudi Arabia to actually making the country as a tourism magnet, as a global tourist hub, through its natural beauty. And because it's in a desert environment, is naturally coming into the mind that obviously the rocks or the barren rock is one of the fundamental aspects, both as landscape forming elements, as well as some kind of a scientific knowledge collector within the kingdom, what could be used as a main power for tourism. Within that, obviously, the tourism is really making a big step up. And this is how we come across with the Harrat Lunayyir, where the Red Sea Global, as one of the largest investment company in the kingdom, decided to develop tourist destinations along the Red Sea and beyond. So before we going into details, just going through what actually the diversity geo-heritage complex paradigm actually meaning. David already covered the roots of these concepts coming from the UK, but by now, by 2025 or 2026, we actually adopting a concept which more or less driven by the Portuguese group and their collaborators by Jose Brilla, which actually looking at the nature that the nature have and a diversity elements what we actually can see with our own eyes, which can be separated to geodiversity and biodiversity is almost self-explanatory issues. But the biodiversity is pretty much kind of an understood even by the plain people or the general public relatively easy because they see all the National Geographic movies, films, there are journals and so on. So there's a very huge avenue and very long tradition to understand what biodiversity is and how that connecting to our life and why it's important to actually maintain the biodiversity high. With the geodiversity, we are a little bit doomed and actually we gradually evolving the concept. It's, I would say that we are still not there yet. However, as an exponential bloom or exponential boom can be seen by the number of research, the diversity of the research, the approaches to the research, and in fact, the definition of the geodiversity as well. Jose Brilla group, which is currently conceptually one of the most accepted and well used and well utilized concept on geodiversity, based on the fact that the geodiversity somehow has to be revolving around as the scientific value, what we can see on those diversity elements of the abiotic nature. What does this mean? It means that essentially, and this is very rough actually, if you read very carefully, you know, the original concept of this geodiversity definition, they're saying the geodiversity, it has to have some kind of a societal connection. So, and that societal connection has to have some kind of a scientific value. So, if you really want to see that something have a geodiversity value, somehow you have to demonstrate that actually there are research on it, there are results, there are some kind of things which actually advancing our knowledge of the abiotic nature. This is, you can say, it's very restricting kind of an approach, because number one issue, and because I'm part Samoan, actually, my family, our family house in Samoa, so I living in a Southwest Pacific, that's where I somehow connected. I can say that when you go to small villages, you see that there are some amazing hills, amazing stuff, aesthetically beautiful, is really nice, and you look, there's no scientific research on those hills, but when you talk with the elderly people, they know exactly the history in their own narrative and their own traditional indigenous knowledge. So then the definition of scientific value is actually not so clear, and this concept is fairly westernized kind of concept, which probably need to be expanded more to the indigenous perspective. But conceptually, it's a workable concept, because you can actually also look the scientific value in situ in the field versus ex situ, let's say in museum. And you also can add to the geodiversity other values, including aesthetic aspects and so on, what in this model looked as geodiversity sites or geodiversity elements. And essentially, the geosites, which is in situ on the field, what you can identify on this framework, will form the core of the geoheritage, what you actually can coin to that site, one site. So if we go further, there are many ways, you know, how actually all these things has been framed, and I'm not really reading through here in detail, but really we have to look for the abiotic elements and somehow some kind of a numerical density approach to actually define it. This is actually very good and very easy, and perfectly opening avenues to using advanced technology, including GIS, remote sensing, and so on, or machine learning, to actually characterize those kind of things in a modern way, or just really in a traditional way, going and looking at those spatial density of certain elements. But then the question is, what are we going to measure? What is actually what we are looking at? And we are running into one of the key aspects, the relative abundance of global, regional, and local scales, what we need to looking at. So if you look at this picture, you really see that this is basically a dark rock, light rock, and something which has something cross-cutting. So intuitively, you can define basically that in the foreground on this picture, everything is black. There's not too much diversity by any mean, you know, what you can recognize by pattern recognition. But when you look at in detail, for instance, in a couple of square meter areas, you can see that there are lots of surface morphological diversities. So the scale of observation obviously play some kind of a role of the definition of the geodiversity in this way. The other issue is the biodiversity, geodiversity paradigm, which recently lead to a concept what they call omnidiversity, where somehow these two, bio and geo, is connected and looking at them together as a dialectic complex system. If you look at this picture up here, this is a very nice picture from the Harrat Khyber, beautiful lava domes, rhyolitic lava domes, mugearite, benmureite, potash-rich silicic domes. And you can see there are some barren rocks with some mafic lava flows and valleys which has all sorts of red and light color kind of deposits, and the vegetation thriving on them. So we intuitively used to think that where we see high geodiversity, that's the area where the biodiversity is high. And in the early researchers almost forcefully try to connect these two things in this way. However, the fact is that it is probably, we do not really understand this concept, and probably in this project we will have a great chance to find, at least contribute to this discussion. Just consider that one of the largest biodiversity on Earth is in Amazonia, like Mato Grosso in Brazil, you know, which is actually a very old rock complex, fairly boring actually from geologically. You really have to work very hard to find in the flat surface with this relatively boring geological context geodiversity, while the biodiversity is super high. Exactly the same you can say in Kenya, for instance, in the Serengeti and, you know, on the plains where you really see high biodiversity, but the geo is fairly limited. So that the direction and the connection between these two things is not very evident. And another concept we need to deal with, the natural capital, which basically somehow putting these values, the bio and geo or the abiotic, biotic kind of values, into some conceptual framing of their value for the society, which is not the diversity, because it's not operating with the number density of anything approach, is operating on the value, which is somehow as a generative concept from the bio and the geo. If you want to put this into context, in this, I created this little diagram long time ago, and it's also in this book, the biodiversity, geodiversity. The bio, basically, we have very clear, like we have a number of species. We can define what the species means. We can define some biochemical kind of concept relatively easier, what we actually want to do. And we can define their spatial or multidimensional context where we want to counting them. In geology, we're facing with one thing, that most of the geological information what we have based on and coming from a two-dimensional map representation. So almost would say that if the geological map is really colorful, the diversity is probably very high in a surface area. But then just think about it, if you have a flat bed or a subhorizontal succession of sedimentary rocks, on the surface, probably you don't see great variation, but in a cliffside, in a coastal region where you have really a 100-meter cliff like in Wales, probably, and that tomorrow you guys will see, you will see a great diversity in that scale, which actually diversity also in a sense of stratigraphical perspective. So the geodiversity is a way not a simple approach to actually somehow express it. If you go to Saudi Arabia, Freike already showed this map. With the initial look, the diversity of the Arabian Peninsula is relatively simple. Arabian Shield, some kind of a Gondwana margin Paleozoic basin, sometimes some kind of a more Tatian style deposition system of the Triassic, Jurassic, Cretaceous things which hosting the oil, and all the Quaternary story, which or the Neogene story, which partially a story of how the Arabian Gulf actually evolved from the big great rivers and uplift and subsidence and so on, plus the evolutions processes of the arid climate. So this is basically, in one hand, is relatively simple, but when you again zoom in, you see the diversity. One of the things, the Saudi Geological Survey established the National Geological Database. This is the website. You can go in and you can access all sorts of geological, geophysical data, many of them freely. Many of them are in GIS-enabled format, VMS or VFS format, or shapefiles. It means that you actually can see the diversity on the through the geological map of the system. Why is it important? Because this geological portal now considered to also host a geodiversity database where we somehow could log in and lodge in all the observed geosites that we identify by some criteria. This is under development, and obviously our project will contribute to this greatly, I believe. So what is the big geodiversity aspects of the Saudi Arabia? The Arabian Shield. These are Neoproterozoic rocks. It's usually about 800 million to just about the end of the 500 million years period. The rocks are essentially an amalgamation of some kind of a terrains, usually terrains which are formed by lateral movement in some large continental margins and closure of convergent processes, and juxtaposing basically those lithospheric fragments to a growing big continental body, essentially of those old continental regions. Between them, when you're closing one of those period of subduction and locking basically a rift side, you actually can generate ophiolites, and those ophiolites, like here, logged into some suture zones, you know, where all those terrains actually amalgamated. Next to that, of course, in each of these arc processes have a volcanic sedimentary basins, have core of usually intermediate andesitic volcanoes, and of course have some batholite associated with them, which actually somehow can be considered as late stage kind of a chambers, some big shallow crustal or mid crustal kind of chambers which actually happen to be there. And all these things somehow, in a very patchy way, also sitting on the oldest continental fragments, which are usually granitoid, mostly tonalitic kind of rocks. This is how it looks like. So you really look like, for instance, in this picture, a beautiful volcaniclastic intermediate volcaniclastic, slightly metamorph tilted successions, or you see some kind of a crystalline granitoid basement, like in the front, cross-cut by intermediate dike, mostly andesite or diorite. And sometimes you see giant calderas, silicic calderas, like in this high terrain region, which have ring structures of intermediate intrusive bodies. So actually pretty complex and changing very rapidly over short distances. Then when you go out from the Paleozoic basins, mostly from the northeast part, northwest part of the Arabian Shield, you are entering to the Tabuk Basin, which is basically a Paleozoic, Silurian, Ordovician successions, Devonian successions, having limestones with mudstones, with a shallow marine environment, dirty environment in a sense of representing something where you have heterogeneous input, probably a succession which deposited in a similar context like present-day Patagonia, or the Neogene Patagonia in South America. So if you in a passive margin, and these areas also cross-cut by some kind of a diatreme features, which forming about or late Mesozoic kind of pipe systems and hydrothermal circulation and silicification. The rocks itself and the landscape has basically, morphologically speaking, great diversity. In a short distances, their geological diversity, in a geological sense, probably limited, because we are looking at a relatively flat sedimentary basin. When you go to the Mesozoic, basically you go to the Tethyan system, a big embayment in the great supercontinents. Saudi Arabia was in the margin again in this large continent, and probably in a much warmer climatic condition, not probably, surely much warmer climatic conditions. And depending on where you are in relationship to large fluvial network, you have muddy, limey successions, mudstone, limestone, muddy limestones, and so on, interbedded with kind of a solitary coral dominated reef systems, lagoons, or carbonate platforms. Why is it important? Because you have basically a very permeable versus very non-permeable subhorizontal unit over large distances, where in this environment, in the time of the deposition, lots of organic material rotted into this bay, producing kerogenes, which actually form the oil and gas. And this, for instance, this succession here is about 2 hours from Riyadh, city of Riyadh. To the north, this is the edge of the world, or the end of the world, which the type locality of the Jurassic, Cretaceous, Jurassic, Cretaceous marine succession of the margin of this system. It's again a subhorizontal bed over large distances, not a lot of diversity you can see, but where you see a morphological step, like in this few 100-meter cliffside, you really can see a huge diversity, including paleontological diversity. Then you're reaching the Cenozoic intraplate volcanism, what Freuke already said, I don't want to go in. It's actually, when you are driving across the Arabian Shield, it's a very different landscape, not just by their volcanic nature, but the relatively monotonous volcanic succession or basalt. And I just can tell you this, I just received a mail that the IUGS Commission accepted the Saudi Harrats as a heritage stone, and it will be widely popularized now. So it has a very good potential that this is a landscape scale elements, rock elements, which influenced everything what happened here, building stone, behavior, lifestyle, and so on of anything, and is really something very exciting. So let's see how we can actually express geodiversity other than just talking about it and talking nonsense long time. So these days, at least in the last 15 years, we are experiencing a transitioning from the qualitative to the quantitative approach to somehow express geodiversity. Interestingly, the Polish geographers are very strong on those in this concept, and there are very good papers like this one published in the Resources, which quantifying geodiversity at a continental scale. Limitations and prospect is a very short, very simple paper. It's about a GIS application for Poland and beyond to express basically the geodiversity, what we can see, using certain parameters, very simple. These are the geodiversity feature, the parameter, what they use to define it, the resolution and the sources or algorithm, what they use as a data source. For instance, the Merit digital elevation model, or a global water body map, the water table depth data set, and so on, the soil grids 250-meter resolution, and so on. So it means that we have lots of digital data in these days for abiotic information. We just have to find a resolution, what we actually want to look at those variations. We have to find something which is relatively well established for basically remote sensing or terrain analysis perspective, like the geomorphon concept, which is published also by Polish authors about 15 years ago. I don't remember the name, but Janowski, I think. But you can choose anything. It's up to you, up to what you actually do, is like terrain ruggedness index and so on. There are many, many measurable, relatively easy to use algorithm to actually express. And then you're looking at the features, like what are the features that you are looking at? Obviously, the geomorphology or morphodiversity is one of the big things. And of course, the morphology or morphodiversity, the easiest things to express it's the slope angle, for instance, anything to do with the slope, because somehow we can have the null hypothesis that diversity is greater in a short distances, 2 or 3-dimensional perspective in a cliffside, because everything exposed, and in addition, it have an aesthetic value. So obviously, that's why we are going for a holiday in a mountain region, because we want to sit outside with a nice coffee in the morning and watching the Alps and the beautiful rugged landscape. So that's why the morphodiversity, especially the slope angle, is one very good aspect. Then you also can express the hydrological diversity or the hydrogeological diversity, which is not the same. One of them is more 2-dimensional, and then the surface, like the drainage networks. You can say the conception that where you have more evolved drainage network, you're very likely looking at more established landscapes. So probably the diversity of the kind of a transitional morpho geodiversity kind of elements higher, while the hydrogeological the diversity expressing more the behavior of the host rock, which may host water or any kind of fluid. Then you can go to the lithological, the classical geological, the topography, you know, what kind of terrain features you are looking at. Obviously, in a big shield volcano has a less diverse kind of concept than a rugged older stratovolcano. So there's a lots of things to do. And with my former PhD student, good colleague from Ukraine, Vlad Zakharovsky, we developed actually a very good, I would say, of course, we say very good, that we can, when we went through the literature, we were saying that, yes, that wait a minute, what for we are doing this geodiversity? Just because we want to have a beautiful, colorful map and number? I mean, what's the purpose of that? Why don't we develop something which actually directly can be applied for let's say, conservation management or planning or urban design or anything. And then we combined basically a valorization of certain elements on the basis of the relative abundance of it, linking to the original UK or British concept of basically the rarity, the representativeness, anything like that. And saying that if we somehow find some kind of a workable system to valorize certain elements, we can actually making a certain grid approach or non-grid approach to actually express that spatially using some kind of a GIS application. This was one of our first paper where we actually used a very old paper. It's published in 1977 about the relative abundance of rocks. And our null hypothesis was that somehow an extrusive or intrusive rock has a kind of a higher value. It's kind of a gut feeling, really. But somehow by now, after, because this paper was 5 years old, I've actually started to convince that actually that we were not so far probably off from the reality, because one way to another, probably a crystalline rock cropping out with dikes and exotic minerals somewhere in a tavern window in Switzerland or in Austria, it's more valuable than walking on a very flat mud plain somewhere. Of course, and that's why I'm provocative here, that in the discussion we can bite into this problem, that is it or what way? But then we actually developed this further and looked at and tested in certain sites, like in Samoa, where we actually developed basically the morphology, like slope model versus geological model based on geology, and developed some kind of a diversity, geodiversity values. And it's somehow actually just by visually looking at the map itself and be on the field and ground truthing it, it's really reflected what we see on the field, especially when we are using not grid-based kind of approach, but use non-grid scaling, basically scaling to the feature what we mapped. You really can see that those areas which are higher, so let's say, don't worry about the numbers, those are relative numbers, doesn't mean it's more low and high. The higher values actually really coincide those areas where young lava flows, cliffs, canyons, interesting morphological assets there, and they are really more eye-catching, if I want to put on that way. So somehow the diversity mixing with some valorization, generating basically a susceptibility map, which is beyond of the simple geodiversity, is more like hot geosite susceptibility. So very likely on those darker color areas, we would be able to find more likely suitable geotourism conservation, suitable kind of a geosites. So then we went further and we tried to, in this book, we actually explored a little bit. That is okay, because somehow we were actually a little bit embarrassed that, well, we can't really come out and go to the Saudi tourism authority. Hey guys, you have a most beautiful white sand beach in the island, is a tropical paradise with a gin tonic sitting in a coastal resort, but actually your geodiversity not so great. So we really tried to explore that. It's not somehow the result what we got is pointed to that, but still we felt like something not right. And suddenly we felt like exactly like what I said before, a couple of slides before, if we are looking at, for instance, here that the main geological entity on these islands are the volcanoes, so probably the location of the volcanoes, their age, their chemistry, and their spatial pattern have some addition. And if we are looking at the corals and the coastal aspects, like what is in the sand, for instance, what type of coral reefs and something exist. And if we combine all those things with the geoarchaeology and the archaeological history of the sea level changes driven human migrations and the Polynesian colonization, suddenly the maps lightened up and we had really a very realistic capture where are the hotspots. But this is actually beyond of the in this classical geodiversity. We also tested the geodiversity like in New Zealand, where we checked the pristine area, a small island again, and we're using different techniques like LiDAR data. We were in New Zealand very lucky because the entire country is at the moment covered by a couple of centimeter resolution LiDAR data, and you can pull out anything. If you have a strong computer, you can create amazing high resolution maps, and suddenly you can see that, wow, it's incredible when actually looking at the morphological assets, you really can see where should be designed, for instance, the tourist path, especially a traditionally strongly captured or controlled island where you really cannot just walk anywhere. And this really have lots of cultural kind of connotation for landing there. So the design for the local tribes for the geo-trial would be very, very well supported by having this kind of information. Okay, so geo-heritage versus sustainable development, ecosystem, geosystem services. This is also a concept what we need to actually understand in a geo-heritage and sustainable development perspective, that the ecosystem services, which looking at basically mostly the bio aspects of the system and its provision, support, and the regulating and cultural services to the human society, can be mirrored to the geosystem and looking at what's there, and we can actually link that somehow to that geo-heritage, volcanic geo-heritage. For instance, if looking at, for instance, the Harrats, this is a set of images from the Harrat Lunayyir, you really can see that there are...
Sorry.
Yeah.
Sorry, I'm just saying, it's 10 to 12 here. So I think officially we're supposed to finish at 12. I just wanted to let you know about this. With your time.
Okay, 5 minutes. I saw it is 27 minutes on my clock. So if we are looking at all these things, you see that there's a golden opportunity to looking at geodiversity parameters, what we could actually looking at, and then we can somehow try to apply one of those methods to actually express the geodiversity. We tried, and we have this one diagram, which is the entire Harrat Lunayyir in a central section, which is kind of an okay, but is pretty much coarse. So I'm pretty sure with new data, new observation, we should be able to prepare those things, because when we are going into the detail, and this is the core area where we probably will look for geological work, you can see that there are great variety of volcanic landforms with their own right. So then, just really briefly covering the first, second, and third 100, the IUGS Geological Heritage Site concept, which is really kind of an important new development for the IUGS. There are designations. These are the first ones, and the second one, you see that Saudi Arabia has 2 sites actually listed now. The Jabal Qadr in the Harrat Khyber, and also the Al-Waqbamar in the second. And in the third 100, I can't really name it, but we have another new one which accepted. It will be announced in November in a special meeting in southern Portugal, where all the third 100 site will be announced. And then what David said, Saudi Arabia have 2 UNESCO Global Geopark, one of them the North Riyadh, based on basically the Mesozoic sedimentary succession, and the Salma Mountain, which is based on the big Neoproterozoic megacaldera and the associated monogenetic volcanic field on the side of it. And then we have another things, and that's what I can say because we got the notification just today, that the basalts of the Saudi Harrats listed as a designation for the IUGS Heritage Stone list because of its extensive presence and landscape forming events. So in conclusion, we can say that Saudi Arabia possesses a high geodiversity region that requires sustainable management, utilizing knowledge-driven geo and bioconservation initiatives, as well as encouraging specialized tourism like geotourism. We have these two books that we prepared with Rashad Mufti. If anybody needs, I can send a link to you and we can share it. Thank you very much.
Thanks a lot, Caroline. I'm sorry, we only had 30 minutes for you. It was really interesting. It was really interesting. Yeah, just wanting to say, so we have to be practical with the time. We've got 5 minutes left. I think we will not really call this a proper discussion, but do we have any questions for Caroline on any aspects of the talk? James?
Yeah, I was very interested in this idea of omnidiversity. And perhaps a reason why geodiversity and biodiversity don't correlate as closely as you might think is there are other factors like latitude. I'm thinking somewhere like Eastern Greenland is incredibly geodiverse, but biologically it's not very diverse. It's at such high latitude. So I was just thinking of that. And then I was thinking about, you mentioned the Serengeti as a place that's got low geodiversity yet incredible wildlife, incredible biodiversity. And of course, yes, its geodiversity is just this Precambrian basement, and then you've got Pleistocene volcanism. But it is actually interesting that the Ngorongoro Ordolangai UNESCO Geopark has been established as there. And so even though it's not very geodiverse, it's got one mega geostory of these volcanoes and drifting plates and all that volcanic sediment that's enriched all the grasslands and also all the biodiversity. So the biodiversity is to do with the geology, even though it's not very geodiverse. There's like one big factor. That's what I was thinking.
Thanks a lot. This is I totally understand where you're coming from. This is coming from a practitioner in geotourism, very interested in wildlife, and that makes a lot of sense because this is what people generally are interested in. I don't know if Carol, you want to comment on this as well.
No, thank you. That's really good. I think this is one of the very new research area, I think, in the geoheritage, geodiversity research in general, because you are 100% right. And sometimes this makes me thinking in context of Serengeti or East Africa, yeah, maybe we are not looking at in a right scale, or we have not asking the right questions what to look, because actually when you're looking at, for instance, the like those lava flows and monogenetic volcanic fields just off from the Mount Kenya and not Mount Kenya, but this is Kilimanjaro and all those big volcanoes. So actually, in that diversity is there, but maybe the scale and the questions are not in harmony in that way to actually to capture that. And the other hand, yeah, I mean, many times the geodiversity may not be in the fact of, you know, landform diversity, like in West Australia, where mineralogy probably the driving force. So I think it's unexplored subject, but I think also need a new research how to actually capturing and linking bio and basically geodiversity. Probably the rainfall, the meteorological, the weathering, it's also need to be coming in, but all those soil forming processes or weathering processes actually geo. So maybe we just not really questioned in our approaches yet to fully incorporate those things. That's why we don't see those more direct connections.
Thank you.
Just follow on that, Ed. Can I propose that we consider cultural diversity in this? Because I actually think cultural diversity does relate really well to the geology. So if we take the example of Saudi, if you look on the east, where there's hardly any rock, but there's a lot of clay, historically people have built mud houses with their beams made of palms. But if you look on the west, you know, I see it in the southwest, in the mountains, you have stone houses that are 5 stories high, and the wooden structures are made of juniper, which grow on high altitudes, which are because of the mountains. So the architectural styles historically and how people's lifestyles are, they respond to the land. And I think, you know, can we look at the links between those two? I think that's really interesting.
This is I think it's really cool.
Just can I answer for
Yeah,
this
go on,
briefly?
Carol. Yeah.
It's a very, very good comment. However, this is one of the main kind of a discussion in these days in the geoheritage, geodiversity research, that should it be included or shouldn't. There are groups which are very characteristically declaring that it shouldn't, because those are additional things. And as a geologist, this kind of question is almost connecting to that kind of approach, that just imagine that you are an alien. You have a starship approaching to the Earth, looking down and try to, from your starship, try to understand the diversity of Earth. What you will see first, you will have geophysical data, you will have some kind of a sensor data about rocks. You don't see those cultural things, obviously, because they are well beyond of the scale of observation tools. Or you go to a planet which has no life, but you still can see, you can express the so-called geo or abiotic diversity. So the question is that geodiversity and in general geoheritage isn't an absolute things, is a heritage of the Earth or the abiotic fundament, or is a generated things which generated in our mind, and without human being you cannot really talk about heritage in that way. And in that case, the social and other things has to be much stronger connected. There's no answer yet. There are many research and many arguments, brilliant ones in very good journals where you can read about it. Personally, I think, and be partially connected to the Southwest Pacific and to the islands, I feel like there is we cannot neglect those things. So they are part of, and the same in Saudi Arabia, they are part of our story. So just as you said, the basalt, for instance, the basalts of the Harrats are playing a very strong geocultural impact beyond of just the geology. It's really like how they build, how people actually behave. Of course, this has not been yet adequately researched. That's another avenue, probably not in this project, but it's really something very exciting things. But that's, again, my personal perspective. Thank you.
Thanks. I agree with your perspective, which is good because we're working in the same research group. But I think the cultural element is important, especially for communication, as you might have guessed from my talk. So we have now to pause for some time. When I say pause, essentially this is the end of the public part of the workshop today. So with the lectures or presentations this morning, what I want to say is this is not the end of any discussion. If you want to contact us, if you want to interact with us, please send us an email, anyone of the group. We might also organize regular meetings in the future if there is enough interest, like, follow-up meetings, mostly remotely through Teams. We could take like an hour or so every couple or every 3 months. Why not? If there are people interested. This is the start of a discussion. This is not the beginning and the end. So let's keep in touch. Thanks all for coming this morning. People on site, we will go to the council chamber. We'll guide you. We'll have some food there. Relax a little bit. And yeah, thank you all again for coming today. I also wanted to give my official thanks to Katie Dobby, who's had to leave for logistical reasons, but she's basically the hidden magician who's been organizing a lot of things to make this possible. So thank you, Katie. I'll tell her personally in a few minutes. Thank you, Carolee, and we'll meet again, as you know, a bit later online again, same link. Thank you.
Yes, thank you very much.
Goodbye.
Bye-bye.